All right, a second part of 5.3. This time we are solving. Find all solutions of cosine of x plus 1 equals sine of x. And we do have an interval. So we will not have general solutions, right? We'll just have a finite number of solutions. Or possibly no solutions if we have if we find nothing, nothing, right? Excuse me. So essentially we're solving for x. So up to this point, we've either been able to get the equation synthesized to one trig function equals something like sine of x equals 1/2 or something like that, or we were able to get like sine squared and cosine in there, and with sine squared and cosine squared we can deal with the Pythagorean identities, right? And also like cosecant squared and all that. But here we only have a single cosine and single sine, right? So it's kind of difficult to put that together because we don't really have a Pythagorean identity going on here. None of them are squared, right? And also we have more than one trig function. So it's not like I can just move the 1. Like if the sine was in here, it'd be easy, right? Just move the 1 to the right and then figure out cosine of what gives me -1. That would be it. Does that make sense? So we have two trig functions here. So what we could do is let's force some squared terms in here. So we have an equation, so let's square both sides of this. Which would be like so. Because it's an equation, right? So we can do the same thing to both sides and they'll still be equal. So this is allowed. And then, so what do I get if I do cosine of x plus 1 squared? So that's going to be cosine times cosine is going to be cosine squared. Cosine times 1 will be plus cosine of x. 1 times cosine will be cosine of x. So I'm doing like the FOIL here. And then 1 times 1? 1, good. And then over here we'll just have sine squared, right? We can combine terms on the left side, right? The two cosines. So we have cosine squared plus 2 cosine of x plus 1 equals sine squared. And it's still kind of looks kind of messy still, right? But at least we have square terms that we know we can work with, right? In terms of using the Pythagorean identities. So now, because we have a cosine squared term and a single cosine term, this looks like this could be a quadratic, like set equal to 0 in the quadratic form. Like x squared plus x plus 1 kind of thing. But I do have a sign in there still, so what we want to do is probably switch this to cosine, right? Something that has cosine. So sine squared is equal to what?
1 minus cosine squared.
1 minus cosine squared. That's going to be over here on the right. So that's from our Pythagorean identity, right? Our sine squared plus cosine squared equals 1. So we can move it around to replace the sine squared. And now we have all constants and cosines, so let's move everything together to the left. So if I move this over here and add this on both sides, over here I would have 2 cosine squared of x plus 2 cosine of x, and the constants happen to cancel out here. Okay. So factor, not too hard because we only have two terms, right? So what do they both have in common? A 2 for sure, and what else? A single cosine, good. So this would be times cosine plus 1. And now it's factored form equal to 0, right? So we can just set each factor equal to 0. So I'm going to have cosine equals 0 and you could think of this as 3 factors here, but we only need to worry about the ones that have an x in them to solve, right? So cosine of x equals 0 and cosine of x plus 1 equals 0. So the 1 we can move over here. So this is cosine of x equals -1. So let's work on cosine of x equals 0. What solutions does that give me? Where is cosine of x equals 0? We'll go back to. What was that? Pi over 2. What else? 3 pi over 2, good. Just bring this up for anybody that's still lost on the unit circle here. Or let me just do it dry out here, because I think it's not connected. So essentially what we're saying is cosine value is the x or the y? X, good. So we know that when is the x 0, right? So we know here it's 0 there, and we know here it's also 0, right? So it's pi over 2. Is this one, and then 3 pi over 2, this one, on unit circle. So I'm going to have x equals all right, what about -1 pi? Okay, good. Now, there's one more thing we have to check here. Because we squared both sides, let me write this down up here. Although it might give us, a path to solving the equation, it might also introduce what they call extraneous solutions that are not real solutions. So we have to check for that whenever we square both sides of an equation. Squaring both sides may lead to that, okay? All right, so let's check each one, and we're going to check in the original equation and make sure that they work. So first we'll do pi over 2. Pi over 2, the original was cosine of x, so that's cosine of pi over 2 plus 1 has to be equal to sine of pi over 2. So then we just solve it, right? So calculate this value, add 1, and you should get the same as sine of pi over 2. And if you don't, that means it's not actually a solution. Does that make sense? So cosine of pi over 2 is 0. This is plus 1, and sine of pi over 2 is 1. So it looks like this is okay. That one passes the test, right? Check. 3 pi over 2. This is cosine of 3 pi over 2 plus 1. We must get sine of 3 pi over 2. Cosine of 3 pi over 2 is 0 plus 1. Sine of 3 pi over 2 is negative 1, right? Because the y value is negative 1 on the unit circle. So here, that does not work. And we had pi as well. So we have cosine of pi plus 1. And do we get sine of pi? This is negative 1 plus 1. And sine of pi is 0. Okay, so our solutions are pi over 2 and pi. So, for example, right, if you guys put all three into as one of your as your answer entry into the platform, it will kind of go. So remember, when you square root both sides of an equation, you're going to have a plus minus answer, right? You have two answers. When you square both sides of an equation, you might have extraneous solutions. So you need to check whatever answers you do get, you have to go back to the original equation, plug them in, and see that they work. Any questions on 6? Yeah.
What happened to the 2?
So the 2 and the factory part, right?
Yeah. What happened to
Since it doesn't have it, if I think of it as a factor, since it doesn't have an x, I can't get anything from it, so you can just ignore it. Or if you want, you can bring it with this factor, like treat this as one whole factor. But if you bring it here, you're gonna have to move it anyway. So if I divide both sides by 2, this will be 0 over 2, so this will still be 0, and then this will still be just cosine of x. Does that make sense? Yeah.
Yeah.
All right, solve. This is 2 cosine of 3t minus 1 equals 0. Okay. So this is, it's not too complicated, right? We only have a single trig term, so it's pretty easy to isolate that. So let's just move the 1 over. And then we can divide by 2 to get the cosine of 3t by itself. Remember, we cannot divide by the 3, right? Because it's inside the function, it's inside the argument. So that we can't get rid of unless we apply some sort of like definition or trig identity or something like that. Okay? So this is where some people get confused. So now it's pretty in simplified form pretty much. Cosine of 3t equals 1/2. This is another place where some people like to use u, but you don't have to. But let's say I say let u be 3t, and that's just because I want to make it look like this, like a single variable, right? Sometimes this helps people that might find this confusing. This might be a little easier to realize what's happening here. So this is just saying cosine of this is 1/2, right? So when is cosine equal to 1/2? Pi over 3 and? Pi over 3 and? 5 pi over 3? Pi over 3 and 5 pi over 3. And notice because we did not see any, we were not given any domain, right, in the original problem. We want the general solutions. So this is cosine, so I'm going to do what here? Add? Yeah, 2n pi or 2 pi n, good. This gives us all the solutions for that, right? Yeah, go ahead.
Sine and cosine is it's 2 pi, correct?
Yes, that's correct. And then because we don't actually want u, right, we're actually looking for t. So now we can plug back the u that we said was equal to 3t. So now I can make this 3t. And this 3t. And solve for t. So over here we will divide by 3. And notice this is going to divide the entire right side. So t, pi over 3 divided by 3 will be pi over 9. And this will be 2/3 pi n. And over here, we got t equals 5 pi over 9 plus 2/3 times pi n. So we have two general solutions here. Any questions on this one? So example 7 had a multiple angle, and example 8 has a call it half angle. X over 2 is the argument for tangent function in this one. So again, fairly straightforward, right? We have the trig function by itself, so we'll just move the 3 and then get rid of this 3 in front as well. Then the 3 in front will divide. Again, if the angle, if a multiple angle or a half angle confuses you, you can use substitution here. So here I would let u be x over 2. So I would figure this out first. Tangent of u is negative 1. When is tangent negative 1?
Oh,
3 pi. We get the.
Tangent is sine over cosine, and then negative 1 over 0 becomes a final.
Tangent is sine over cosine, y over x, right? So y over x, when is that negative 1?
That pi. No, that would be 0. Would it be possible?
Let me check here. I always forget which one is the one that doesn't open right. Yeah, that's that one. So they have to be the same value, right? But one has to be negative and one has to be positive. So go around here, not this one, right? This is 1. This over this will be 1.
Pi over 4. 3 pi over 4.
Yeah, 3 pi over 4. Same value, but this is negative, this is positive.
Okay.
We got 3 pi over 4 here. And this will be plus. Tangent is period is pi. Pi n. Okay. Let u be x over 2. Solve for x. This will be what? 3 pi over 2 plus 2 pi n. So once we distribute the 2, that's what we get. Questions on this one? Example 9.
got secant squared minus 2 tangent of x equals 4. We do have a squared term, a squared trig term, right? In a single trig term. So it might be a quadratic kind of situation. So we want to probably have the same trig function. So I can change, tangent is hard to change, right? Because I can do, I can change it to maybe sine cosine or something like that, but then now we're adding a fraction in, and it's not even, this isn't even sine cosine, does that make sense? So it looks like it's much easier to plug something in for secant. So secant squared is equal to what? 1 is tangent squared, good. Minus 2 tangent. So it looks like here I can just drop the parentheses, right? And then also I'll move the 4 over here. I'll have 1 minus, oh, actually, let's do the tangent squared first. So I'll have tangent squared minus 2 tangent of x minus 3, looks like. Okay, now you can factor from here. Good. If not, you can, if you need to change it to u substitution, you can. Normally we let u be the middle trig term. So it would look like this: u squared minus 2u minus 3 equals 0. And we can factor this, looks like. u, 3, 1. Minus 2 in the middle, so it's got to be minus 3, right? And positive 1. So minus 3 plus 1. And then double check that it works for the constant also, right? Negative 3 times positive 1 is negative 3. Because if sometimes you're able to get this middle one, but maybe these signs don't work for this sign, and in that case you'll have to do quadratic formula. Okay. So each of these factors, if I let u be tangent of x again, I have tangent of x minus 3 times tangent of x plus 1 equals 0. And then we take each factor, right, so they equal to 0. So this factor has an x in it, and this factor does too. Done. Let's do that second one on the right first. Tangent of x is equal to negative 1. What would give me that? What was it? 3 pi over 4? 3 pi over 4. This would be plus pi n. Good. And then the other one is more difficult, right? So the other one we were actually, because it's a 3 and we can't do this one with the unit circle. This one we would write it as x is equal to arctan of 3. And then we'll add the n pi n here. Plus pi n. In the book, they came up with x is equal to negative pi over 4 plus pi n. Is this the same thing?
She's still one.
Yeah, negative pi over 4 would be the same, it's the same set of solutions, right? But if you think about it, this is 3 pi over 4, and this n can be any integer, right? 1, 2, 3, or negative 1, negative 2, negative 3. So if I make n negative 1, right? Negative 1 times pi is negative pi. 3 pi over 4 minus pi will be negative pi over 4. So it will be the same as the n over 4.
And so forth, right? So it represents all of them, all of those solutions. Good. Any questions on that one? All right, and I think last one for this section. Because we have not seen quadratic formula in this situation yet. So this is one of those examples. Solve sine square root of x minus 3 sine of x minus 2 equals 0. We do have an interval for this one.
It's already in that kind of handy quadratic form, right? Square term, single term, and then constant equals 0. So nothing to change or move. We just need to see if we can factor it.
So if we try the u substitution first, just to see if we can factor it, this would be u squared minus 3u minus 2. So you would probably check this first. u, 2, 1. And in this case, to get a minus 3u, I would need to have a minus 2 and a minus 1. But as you can see,
Minus 2 times minus 1 does not give me a minus 2, right? So that means that we can't factor this.
so we'll have to go straight to quadratic formula. Now, we need A, B, and C, right? So what is A, B, and C? So A would be 1, right? Coefficient for sine squared is 1. Then we have minus 3. And the constant is minus 2. We got negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Minus minus 3, of course, will be positive. 3 plus or minus. We got 9, and then there's 2 minuses, right? So plus 4 times 1 times 2. Looks like 8. And then 2 times 1. By the way, this is when you do quadratic formula, it's x equals technically. So right now it's u equals because we're doing it off that u equation we built, right? So we have 3 plus or minus square root of 17. All over 2. Okay. Let's put the u back as sine. So this now says sine of x is equal to 3 plus or minus square root of 17 over 2. Break this up into two different sine equations. So this is where we would break out the calculator and get an approximation for this, right? So we would do 3 plus square root of 17 over 2, and then also 3 minus square root of 17 over 2. The first one will give us approximately 3.5616. 3.5616. The other one will give us negative 0.5616. Like that. And then from there we could just graph sine. Or you could maybe do arc sine, right? You didn't have it anyway. But you could graph sine, and we can try to see where this y value is, right? Where this y value is, and then see where what the x would be, approximately. If you do this, you should get, let me do the wavy equal sign here. One of them would be roughly, actually, should we do it that way? Let me just show it to you, because I feel my drawing won't be as nice. We are here. Okay. So notice the first one, right? The first one was 3 point something, 3.5. Yeah, the other was negative. Remember the range, right? We talked about this before. From -1 to 1. So obviously we can't reach this y value, right? So nothing from here. Impossible for the first one. So then we look at the other one. Negative 0.5616. So about here. And you can see the x. You can also do this as the arc side, right? Of that. That's what you get. Do it in your calculator. Technically, but they did give us an interval, so our solutions have to be within the 0 and 2 pi. So if you get this as an answer, right, and this is the other trick you should know about using your calculator. Yeah, this would work and give you this, right? But then you have to convert this so that it fits in your between 0 and 2 pi. Does that make sense? So what do you do to this? Add. In this case, 2 pi. Does that make sense? Yeah. And remember, 2 pi gives you it goes a full revolution, right? So it gets you to the same place, but it'll give you a positive number, not a negative number, because we need to be between these two. Okay? Yes.
Oh.
For the
So what would be an answer? Because it would be.
What do we have? What did they do? So we got this one, 3.7, and then you did 2 pi minus 5.6. Solutions for this one are those two. Yeah, so from 0 to 2 pi, so 2 pi is roughly 6.28. That makes sense? 6.28. So you want your answers to be between 0 and 6.28. Because 2 times pi is 2 times 3.14. So both of these are between 0 and 6.28. That makes sense?